So I would like to show you a video of how I would solve a problem like this one. This comes from homework 10.4. I think this is a copy of the second question. A rectangle is drawn so that the width is 2 feet shorter than the length. So I'm going to underline that. The area of the rectangle is 3 square feet. Find the length of the rectangle. So what I find interesting about this problem is that there are two quantities in this question whose value is unknown. The first quantity whose value is unknown is the width of the rectangle. And for short, I'm going to refer to that with a capital W. The second quantity that's unknown is the length of the rectangle, and I'm going to refer to that with a capital L for short. Now, corresponding to these two unknowns, I have two statements about this rectangle. One about the rectangle's, essentially the rectangle's proportions, its shape. The width is 2 feet shorter than the length. So I'm going to try and translate this English statement into a mathematical statement, into a mathematical equation. The width is. Now pause for a moment. The width is 2 feet shorter than the length. What do you think you would put on the right-hand side of this equation to capture that? Well, if the width is 2 feet shorter than the length, then the length has to be decreased by 2 units if I want to get the width from that. The width is 2 smaller than, shorter than the length. All right, I would now like to try and translate the second statement in this problem into an equation. The area of a rectangle is 3 square feet. Now, folks, pause and remind yourself, for a rectangle with this length and width, what formula do we have for the rectangle's area? The area of a rectangle can be found by taking the length and multiplying that by the width. So if someone says the area is 3 in the units of square feet, I would translate it into an equation L times W equals 3. Now, both of these equations are supposed to be true at the same time for the same rectangle. So I'm going to use a bracket to indicate that these are a system. We want both of these to be true at once. And to solve that system, I think that this one is ripe for the use of solving by substitution. In particular because in the first equation, W has already been isolated, which means I can substitute the W in the second equation for its alter ego, L take away 2. So that brings me to the equation L times L minus 2 equals 3. Now on your own, see if you can solve this equation by yourself. Pause the video, give it a try. Now let's do it together. I would solve this equation first of all by distributing. L times L is L squared. 2 times L is 2L, equaling 3 on the right-hand side. Now because this equation is quadratic, because it contains an exponent of 2, my method for solving this usually begins with me subtracting 3 from both sides for the purpose of getting a 0 on the right-hand side. For quadratic equations, whether you're using factoring or you're using zero product property, or I should say whether you're using factoring and zero product property, or if you're using quadratic formula, both of those methods require 0 on one side of the equation. So for quadratics, that's always my first move. Now this one, I think, fortunately for us, actually can be factored. I take -3 and +1, those two numbers multiply to -3 and add up to -2. So this tells me by zero product property that L would have to be 3 or L would have to be -1. Now this is the moment where I'm going to remember that L represents a real world quantity, and in particular a real world length. And it doesn't make sense for a length to be negative. So I'm going to discard the solution. It was perfectly valid mathematically, but I'm going to discard L equals -1 because here in the real world, length can't be negative. And my final answer to this question would be L equals 3.